In this video, we're going to look at a few different strategies we can utilize when solving a variety of equations. Let's start with 4-4 part A. To start, we're going to undo what's being done to the absolute value bars. So we have 4 times the absolute value of 8x minus 2 equals 8. So I will start by dividing both sides by 4. 4 divided by 4 is 1, so I'm left with the absolute value of 8x minus 2 is equal to 2. Now, you know from the past that when we have the absolute value, that means that what's inside could either be equal to 2 or negative 2. So I'll go ahead and set up those two separate equations. 8x minus 2 could equal 2, or 8x minus 2 could equal negative 2. So now, undoing the operations that are being done, on the left, I'll add 2 to both sides, which will give me 8x is equal to 4. And then undoing what's being done to x, I'll divide both sides by 8 to get x is equal to 1/2. On the second part of the problem, I'm going to undo what's being done to 8x by adding 2 to both sides, which give me 8x is equal to 0, and then dividing both sides by 8 to undo the multiplication gives me x is equal to 0. Checking my two solutions, if I put 1/2 in, I'll get 8 times 1/2, which is 4. 4 minus 2 is 2. The absolute value of 2 is 2. And 4 times 2 is equal to 8, just as it shows up above. Checking the other solution I got, I have 4 times the absolute value, 8 times 0 minus 2. That's going to give me 4 times the absolute value of negative 2, which again is 4 times 2, which is 8, just as I should get. The next problem we're going to look at is 4-4 part E, which I've rewritten in the middle of the page. Now, I don't know about all of you, but I would prefer to not work with fractions if I don't have to. So I'm going to rewrite this to make it a little more user-friendly. I'm noticing that my 3 denominators, I've got x, 3x, and 3. So if I were to multiply every single term by 3x on both sides, first of all, I'm doing the same thing on both sides of the equation, so that would be fair, and it would enable me to get rid of the denominators that I have. When I do that, I'll show you the entire thing here. I have 15x over x plus 3x over 3x equals 12x squared over 3. And then I'm able to simplify 15 plus 1 equals 4x squared. From here, I'm able to combine like terms on the left to get 16. I have 16 is equal to 4x squared. To isolate my x squared, I'll undo the 4 by dividing both sides by 4. I get 4 is equal to x squared. And then undoing the squared means I would take the square root of both sides, remembering that that's actually going to give me 2 solutions. It could be a positive 2 or it could be a negative 2. The last problem we're going to take a look at is part H. And for this, we're going to use the look inside method. So when I look at this problem, what I notice is it's equal to 0. And since right here I'm subtracting 5, I know that these two things together would have to equal 5 in order for me to end up with it equal to 0. So looking in that and noticing that I have a 4 in front here, if this were 4, then this would have to be 1. Now I'm thinking, is there a way that I can do this so I can put the same number in for x and get 4 and 1? And noticing since they're both x plus 2, if I were to put negative 1 in for x, then this would be equal to 1, and this would be equal to 1. 1 squared is 1. 4 times 1 is 4. And so I'd have 1 plus 4, which is 5 minus 5, equals 0. One of the issues with look inside is the fact that we may miss one of the possible solutions. And so let's try another strategy to see if we got all the solutions that we should for 4-4 part H. So if I use u substitution and have u be x plus 2, I would have u squared plus 4u minus 5 equals 0. Now this is a factorable quadratic. Okay. So once I factor it, I'm able to set each of those equal to 0. So I'd have u plus 5 is equal to 0. Subtracting 5 from both sides, I would get u is equal to negative 5. And u minus 1 equals 0. We'll get u is equal to 1. Now, to find my x values, I can now go back to the original. So I can do negative 5 is equal to x plus 2. And subtracting 2 from both sides, I get x is equal to negative 7. And then over here, I can do 1 is equal to x plus 2. Subtracting 2 from both sides, I get x is equal to negative 1. So notice I do get the same answer that I got when I looked inside, but I also am getting this additional answer that I missed the first time through.